Okay, now we're doing volume of solids or objects part 2, and these are more about a line. Okay, up to now we haven't been doing about a line, we have just been doing about the x-axis. Okay, so figure 1, figure A, that was just pi times r squared, right? Because we had just one curve and we were just finding the volume underneath that curve and then spinning it. Figure B is what we did on part 1 as well, and that is where we have our outer radius of the outer minus the radius of the inner, right? That is the washer. Okay, so figure 1 is the disk that we did first, and then B is the washer. Now C and D are the new ones. Okay, if now you have a line above and you're rotating it around, so in this case y equals C up here, right? Because it's above, go C minus G of x for your outer, because see how this is the farthest away, minus the inner, right, which is right there. Now, in figure D, do you see how we are above the line that we're revolving around? So that's where we're going to do f of x minus c, because f of x is the farthest away. Okay, that's been cut off, but this is f of x. And then we're going to go g of x minus c. This is g of x. Okay, so if it's underneath, put the c second. But if it's over top, like is in figure C, put it c minus. Okay, now, and then we're going to talk about this. To rotate around the vertical line x equals c, express our outer and our inner as functions of y and integrate along the y-axis. Okay, so those are the definitely the higher level ones, and we'll do one of those. And then I'll show you a way that you would do instead of rotating using our outer and our inner if you're going to go around the y. Okay, so let's do this one. Here's an example that we're rotating about a horizontal axis, and we're going to rotate about y equals -3. So y equals -3 is down here, so it's below, right? Now for these, when you have to find the region of what they have in common, you have to first find out where they intersect. Okay, so this is like the volume of a wedding band. So the first thing we have, because in the other ones we've done up to now, they have given us, right, the points that they want us to find between. But this one, we're going to have to go find points of intersection. And by doing that, all you do is make x squared plus 2 equal 4 minus x squared. So you're making f of x equals g of x. Okay, so that's going to be 2x squared. If I bring that to the other side, I'm going to bring -2 to the other side, equals 2. Then we're going to divide by 2 on each side. I'll get x squared equals 1. So x equals plus or minus 1. Those will be our 2 points. Now, the second thing, let's find our radius, or radii, I should say, because we've got 2 radii. So, the first one, our outer. Okay, so our outer would be g of x minus what's beneath it. So I'm going to go g of x minus -3. And my r inner, I'm going to go g of x minus -3 as well. Okay, so that goes to g of x is 4 minus x squared plus 3, and my inner is x squared plus 2 plus 3. So this is 7 minus x squared and x squared plus 5 is our inner. So let's go find the volume now. So volume about y equals -3 equals pi. I've got -1 and 1. We're going to go r squared the outer minus r squared the inner dx. So this equals pi -1, 1. We got 7 minus x squared. Oops. Yeah, 7 minus x squared squared minus x squared plus 5 squared dx. Okay, good times. So I've got to take 7 minus x squared and multiply 7 minus x squared. So let's write this down, -1, 1. Okay, and then to do that, I will get 49 minus 14x squared plus x to the 4 minus x to the 4 plus 10x squared plus 25. So if we get that all together, -1, 1, okay, that will give me 24 minus 24x squared dx. Oops, forgot my pi. Okay, equals pi. Now I'm going to do my derivative or integral 24x minus 24 over 3, which is 8x cubed. -1, 1. So this will equal pi times, pi times 24 times 1 minus 8 times 1 cubed minus 24 times -1 minus 8 times -1 cubed, and this will give me pi, so we've got 24 minus 8 minus 24 is plus 24 minus +8 is minus 8. So this equals 32 pi units cubed. Okay, how was that? Got more fun ahead. Okay, I'm going to do 2 more questions. Okay. So here we have the volume of a washer rotated about y equals 15 between 0 and 3 interval. Okay? So our outer, our radius outer, now since it's above, we're going to go 15 minus f of x, and our inner is 15 minus g of x. Okay? So let's do 15 minus 9 minus x squared equals 6 plus x squared. Our inner is just 12, right? Or 15 minus 12, I should say, which is 3. Okay, so this one's not so bad. So volume equals Pi, we're going from 0 to 3 of r outer, 6 plus x squared squared minus r inner, which is 3 squared. Okay, and that's dx. Okay, we've got to get that all together. Volume equals pi 0, 3, 36 plus 12x squared plus x to the 4, all minus 9 that came from there, dx. Volume equals pi 0, 3. Okay, so now I'm going to take the, I'm going to just take the integral of it now. I don't know why I was doing that, okay? So I'm going to take the integral. Oh, no, I didn't get everybody together yet. Sorry, getting ahead of myself. 0, 3. Okay, because I can get that 36 and negative 9. So it's 27 plus 12x squared plus x to the 4 dx. Now I'm going to take the integral. 27x plus 12 over 3 is 4x cubed plus 1/5 x to the 5 dx. Volume is pi times 27 times 3 plus 4 times 3 cubed plus 1/5 times 3 to the 5. And that's all minus 0. Okay, we put that in. Volume would equal 1188 over 5 pi cubed units. Okay. Now, so that's how you would do them if they're around the a horizontal. Now we're going to do revolving around a vertical axis. Okay? So find the volume of solid obtained by rotating the region under the graph of fx equals 9 minus x squared between 0 and 3 about the vertical axis x equals negative 2. Okay? So this one you almost want to like turn if you can, and you want to kind of be looking, so like this is the bottom, right? So if you turn this sideways and you're looking here up at it, then this is very similar to what we were doing before. Now, when you're doing it about a vertical axis, these are a little bit more tough. You've got to convert everything to x equals. Okay, so that's the first thing you have to know. And the second thing, we're still going to be, again, if I'm looking from there, this is under it, right? So then I will go minus c. So first of all, let's convert both of these to x equals. So I got y equals 9 minus x squared. Y minus 9 equals x squared. Now x is going to be this equal to the square root of y minus 9. It's not going to be plus or minus since x is greater or equal to 0. Okay, so we're not going to make it too tough. So now my r outer will be, so the top one is, right, square root y minus 9 minus negative 2, and r inner is just 0, okay? 0 minus negative 2, because it was x equals 0 that we're doing, which is the y-axis. X equals 0 is the y-axis, right? That's this right here. Okay? So volume equals pi. Oh, here's another trick too. Forgot to say that our domain is between 0 and 3, but we have to put our domain into our formula to get our range. Okay, so we put this into here to get our y value. So if I put in 0, right, then I get answer 9. So y equals 9 times, so I'm going to find my range now. 9 minus 0 squared, this equals 9. And then y equals 9 minus 3 squared equals 0. So I'm doing between when y is greater or equal to 0 and less than or equal to 9. Okay? So if you look up above, that's where we get our, here's where 9 would be, and here's where 0 is. Okay? Because I put in my x's of 0 and 3, and I get those y values. Okay? So this looks like an x, but it's not supposed to be. It's supposed to be a y. Okay? So yeah, that's tricky. Very, very, very tricky. You got to use the range when you're doing these because we're just putting in y values, right? So we can't put x values in. So volume is pi 0, 9. Our outer, we've already figured out, is square root of 9 minus y plus 2 squared minus 2 squared. Okay, when you FOIL that out, oops, I should be putting dx here. When you FOIL that out, v equals pi 0, 9. 9 minus y plus 4. 9 minus y plus 4, and then the minus 4. Okay, v equals pi 0, 9. And this is 9 minus y plus 4 root 9 minus y. dy. Why am I putting dx? It is dy, right? I'm taking the derivative, or the integral to y. So a lot of little things to watch out here. First of all, make sure we're putting in the range, and make sure we're always going dy. Okay, so now we're going to find the integral of this. Okay, so volume equals pi 0 to 9. The integral, that would turn into 9y minus 1/2 y squared. I shouldn't have put this 0 to 9 because I am finding the integral right now. Minus 1/2 y minus, now that's to the 1/2. This is to the 1/2, right? So that means I'm going to go to the 3 over 2. Sorry, that's plus. So 3 over 2, so that's 2/3. 2/3 would be 8/3. And then 9 minus y to the 3 over 2. And we've got to divide by the derivative of the inside. So derivative of negative y would be -1. Right? And 9 would be nothing. So that gets all divided by -1, which is going to turn that into a negative. So volume equals, oh yeah, and then I've got to put 0 to 9 here. Volume is pi times 9 times 9 minus 1/2 times 9 squared minus 8/3. Here's a minus 8/3 here. because of that minus 1. That's tricky. 9 minus 9 to the 3 over 2. Minus, so 9 times 0 minus 1/2 times 0 squared minus 8/3 times 9 minus 0 to the 3 over 2. Okay, when you put that all in, you get a volume of 225 over 2 pi units cubed. Okay, so that is definitely a tough question. But, you know, the AP exam is going to have some tough questions on it, obviously. So I have given you questions to work on in your package. And because I think if I go to the next page, no, here's your homework, sorry. So if you're at home and you don't have access to, or you didn't get the package, here are the questions. And if you go to my website, all of the solutions are up there.